Hello everyone. In this video, we'll be solving system of linear equations with two variables. We'll be finding solution to system of linear equation with two variables, that is x and y, using Gauss elimination method as well as Gauss-Jordan method. So let us solve first example using Gauss elimination method. So here the question is, solve by Gauss elimination method and the equations are x plus y is equal to 2, 2x plus 3y is equal to 5. For these two equations, we have to find its x value and y value using Gauss elimination method. So here, when we are applying Gauss elimination method to solve any system of linear equation, then the first step is conversion of these equations in terms of matrices. So here first, we have to express these two equations in terms of matrix, that is matrix A, where A matrix is always a matrix of coefficient. So here in first column we have to write coefficient of x. In first equation coefficient of x is 1 and in second equation coefficient of x is 2. So here we have 1, 2. Similarly, in second column we have to write coefficient of y. So coefficient of y is 1 in the first equation. Coefficient of y is 3 in the second equation. So here it is 1 and 3. This is about matrix A. Then next we have to write matrix X. So always matrix X is a matrix of variables. In this equation, variables are x and y. Next we have to consider matrix B. So matrix B is, in the equation, whatever the constant term we have on the right side of the equation. So constant involved on the right side of the equation we have to mention in matrix B. So the constants are 2 and 5. So here we have 2 and 5. So in the first step, we have converted the given equations in terms of matrix A, matrix X and matrix B. Next we have to consider augmented matrix AB. Now here augmented matrix means it is a combination of matrix A and constant matrix, that is B. So let us consider augmented matrix AB, that is 1, 2 in the first column, 1, 3 in the second column, and then consider matrix B elements, that is 2, 5. So this is what? This is augmented matrix AB. Next, when we are applying Gauss elimination method, then in next step, with the help of row transformation, we have to convert matrix A in terms of upper triangular matrix. Now upper triangular matrix means below the diagonal, whatever the element is there, that element we have to reduce as 0. So as it is 2 cross 2 matrix, so below the diagonal only one element is there, that is 2. So this 2 we have to reduce in terms of 0. For that we have to apply row transformation. Observe here, 2 belongs to second row. It means we have to apply the row operation for second row. So here R2 changes to R2 minus 2 times of R1. With the help of this R2 changes to R2 minus 2 times of R1 row transformation, easily we can convert this lower term below the diagonal, this 2 we can reduce as 0. So here we are applying transformation only for R2 row. It means R1 row elements will remain as it is, that is 1, 1, 2. So R1 row elements will remain as it is, only we are applying this transformation with R2 row element. So just observe here, R2 row first element is 2. So 2 minus 2 into its corresponding R1 row element is 1. So here 2 minus 2 will get 0. So this element is 0. Next, R2 row second element is 3 minus 2 into its corresponding R1 row element is 1. So here we have 3 minus 2, that is 1. Next, R2 row third element is 5 minus 2 into its corresponding R1 row element is 2. So here 2 2s are 4. So 5 minus 4 will get 1. Now we can observe that below the diagonal, see, these two are the diagonal elements of matrix A. So below the diagonal, complete element is converted in terms of 0. Now after this, again we have to convert this augmented matrix AB in terms of equation. Now again we have to convert it in terms of equation. So observe, first column is for x variable, second column is for y variable, and the third column is constant, that is from matrix B. So this is constant column. So here when we convert this augmented matrix again in terms of equation, so just observe 1 into x, that is x plus 1 into y which is equal to constant element 2. So the first equation which we have got is x plus y is equal to 2. Next, 0 into x, 0. 1 into y. Now this is equal to constant 1. So here we are getting y variable answer directly. Now this y variable answer we need to substitute in the first equation. X plus y value is 1, which is equal to 2. Therefore x is equal to 2. Take it on the right side, then minus 1. Therefore x is equal to 1. It means for the given equation, its x value is 1 and y value is 1. So here when we are solving these two equations using Gauss elimination method, then we can observe that we are getting x value as 1 and y value as 1. So here whether whatever the answer we have got is correct or no, that again we can verify by substituting it in equation 1 or in equation 2. So here x value we have got 1 and y value we have got 1. So 1 plus 1 gives us 2. Similarly, substitute answer in second equation also. That is 2 into 1 plus 3 into 1, add it, will get 5. It means whatever the answer we have got, that is x is equal to 1 and y is equal to 1, that is correct one. Now let us solve this example using Gauss-Jordan method. So the question is, solve by Gauss-Jordan method and the equations are 2x plus 3y is equal to 5, 3x minus y is equal to 2. So these two equations, x and y value we need to calculate using Gauss-Jordan method. For that, first we have to convert these given equations in terms of matrices, that is matrix A, matrix X and matrix B. Here matrix A is a matrix of coefficient where in the first column always we write coefficient of x. So here coefficient of x is 2 and 3. Then write coefficient of y, that is 3 and minus 1. Matrix A is a matrix of coefficient. Then x is variable matrix and in this equation variables are x and y. Next we have B matrix. So on the right side of the equation, whatever the constant term is there, that we have to mention in matrix B. So once we write A matrix, X matrix, B matrix, next we have to consider augmented matrix AB. It is a combination of matrix A and matrix B. Matrix A elements and matrix B elements we have to write together. Then next, we are using here Gauss-Jordan method. So in Gauss-Jordan method, what we have to do means, below the diagonal as well as above the diagonal, whatever the element is there, those elements we have to reduce in terms of 0. So here below the diagonal we have element 3 and above the diagonal we have element 3. So these two elements we need to reduce in terms of 0. So here to reduce it in terms of 0, we have to apply row transformation. But when we are applying row transformation, first we need to observe the first element of the matrix. It should be always 1. Here it is 2. See, first element is not 1, but we can reduce it as 1 in terms of 1 by applying the transformation R1 changes to R1 divided by 2. 2 belongs to first row, therefore apply transformation for first row, that is R1. This 2 we are reducing as 1. It means divide R1 using 2. Then we'll get here 2 divided by 2, 1. 3 divided by 2, 3 by 2. 5 divided by 2, that is 5 by 2 as it is. So here row transformation is only for R1 row. Only R1 row elements will change. It means R2 elements will remain as it is. That is 3 minus 1, 2. So first we have reduced the first element of the matrix as 1. Next we need to reduce this 3 in terms of 0. So this 3 belongs to R2 row. So apply condition for R2 row, that is R2 changes to R2 minus 3 times of R1 row. Now for our R2 row elements we have to apply this particular transformation. R2 row first element is 3, so substitute 3 minus 3 into. Its corresponding R1 row element is 1, so 3 minus 3, 0 will get. Next, R2 row second element is minus 1, minus 3 into. Its corresponding R1 row element is 3 divided by 2. Then by using LCM concept, if we simplify this one, 2 into minus 1 minus 2, minus 2 minus 3 into 3, 9 it is. So minus 2 minus 9 minus 11 divided by 2 will get. R2 row last element is 2 minus 3 into. Its corresponding R1 row element is 5 divided by 2. Again using LCM concept, 2 into 2, 4. 4 minus 5 3s are 15. 4 minus 15 will give us minus 11 divided by 2. So here it is minus 11 divided by 2. So observe here, below the diagonal one element we have reduced as 0. Now above the diagonal this particular element we need to divide as 0, but before that its corresponding R2 row element we have to reduce as 1. So this minus 11 divided by 2 we have to reduce as 1. For that apply the transformation. Minus 11 divided by 2 belongs to R2 row. So apply R2 changes to R2 divided by minus 11 divided by 2. Then R2 row elements will become 0, 1, 1 and R1 row elements will remain as it is. Next, now we have to reduce this 3 divided by 2 as 0. For that, apply transformation. 3 divided by 2 belongs to R1 row element. Therefore, R1 row changes to R1 minus 3 divided by 2 times of R2. 3 divided by 2 times of R2. R1 row first element is 1. So substitute minus 3 divided by 2 times of its corresponding R2 row element is 0. So this is 1 minus 0, 1 will remain. Next, R1 row second element is 3 divided by 2 minus 3 divided by 2 into its corresponding R2 row element is 1. So 3 by 2 minus 3 by 2 will get 0. Next, R1 row, last element is 5 divided by 2 minus 3 by 2. Its corresponding R2 row element is 1. So here 5 minus 3 will get 2. So 2 divided by 2 will give us 1. So this is the required augmented matrix after applying row transformation, because you can observe here below the diagonal as well as above the diagonal elements are 0. Now again we need to convert this augmented matrix in terms of equation. So here first column represents x variable, second column represents y variable, and third column represents constant. Therefore 1 into x plus 0 into y, 0, and the constant is 1. Therefore x is equal to 1. Next, 0 into x, 0, plus 1 into y, and the constant is 1. So here this gives us y is equal to 1. It means the required answer for the given question is x is equal to 1 and even y value is 1. That we can verify by substituting in any one of the equation. So let us substitute in first equation, that is 2 into 1 plus 3 into 1. Obviously it will give us 2 plus 3, 5. It means whatever the answer we have calculated, that is correct. Thank you.